Algebra 2, Lesson 116, Fundamental Counting Principle and Permutations, Probability, Independent Events. Okay, so let's start with the Fundamental Counting Principle and Permutations. I'm going to go straight to an example problem so you guys can understand what we're talking about. Example 116.1. They ask, how many different ways can the numbers 3, 5, 7, and 8 be arranged in order if no repetition is permitted? So, in order to get the number of permutations or the number of possible ways that these can be put in order, we have to take the number of possibilities and multiply them by each other. The book actually does a great job exampling this. I don't even have to write this on my paper. So we've got 1, 2, 3, 4 numbers, right? We want to arrange them in order, so that means we're going to have 4 slots to put items in, okay? So in the first slot, we ask how many options do we have to put in this slot. It doesn't matter what we choose. We want to know how many options we have. We have 4 numbers to choose from. We're not allowed to repeat any numbers, so there's 4 options to be put in the first box. Once I've put one option in the first box, I now have to ask myself, how many options do I have left to put in the second box? Well, since I can't repeat whatever I put in the first box, that means I've got 3 options left for the second box. And then so forth. And the third box, I only have 2 options left. And then by the time I get to the fourth box, I'll only have 1 number left in my hand. So I put those numbers based on how many options I have for each box. And then to figure out the number of possible different ways, I just multiply those different options by each other, which is what they show here. 4, 3, 2, 1. 4 times 3 times 2 times 1 is 24 ways. So that is a permutation for groups. Now, what happens if we can repeat the numbers? Or let's say we have a 4-letter sign. They say how many 4-letter signs can be made from the letters in the word equal if repetition is permitted, meaning that we could repeat the letter E 4 times. So if we look at the word equal, we have 1, 2, 3, 4, 5 letters, so that's 5 options. You'll see in the first slot, we have 5 options. We're allowed to repeat. So in the second slot, we have 5 options. We're allowed to repeat. In the third slot, we have 5 options. So since we're allowed to repeat and we have 5 options to choose from in 4 slots, each slot has 5 options. And then to find the answer, again, we just multiply all of our slots by each other. So 5 times 5 times 5 times 5, 625 possible arrangements. That's the answer. Again, the book does a great job of explaining permutation, so that's as simple as those problems get. The more I guess you would call it more complex. It's the same concept either way. A multiple choice quiz has 8 questions. There are 4 possible answers to each question. How many permutations of the answers are possible? So I've got 8 questions or 8 slots. Each slot has 4 possibilities. I can repeat those answers across the slots. So 4 times 4 times 4, 8 times, gives me 65,536 ways to answer that quiz. Okay, let's go back to a non-repetition one. They ask how many 3-letter signs can be made from the letters in the word numeral if no repetition is permitted. Okay, so numeral has 1, 2, 3, 4, 5, 6, 7 letters. So if there's no repetition and I've got 3 slots, the first slot has 7 options. I lose 1 option on the second slot, so the second slot has 6 options. The third slot has 5 options. 7 times 6 times 5, 220 possibilities. Okay, and then this is all application of the fundamental counting principle. The fundamental counting principle says if you've got options and slots, all you do is put down your options next to each other and multiply them. So that's what we're doing here. Now let's see here. So those are all permutation problems. Next we're talking about probability. Probability is simply explained as a ratio. And that ratio is the number of favorable outcomes over the number of possible outcomes. All right. So let's say in a probability problem, Okay, so let's just use a dice. Okay, so let's say we roll a 6-sided dice, and we want to know what's the probability of us rolling the number 3. Well, the number of favorable outcomes in that scenario is 1, because there's only one number 3 on a 6-sided dice. So one favorable outcome. Number of possible outcomes, it's a 6-sided dice, so there's 6 possibilities. So the probability of rolling a 3 is 1 to 6. Now, let's say we wanted to find the probability of rolling an even number, okay, on a 6-sided die. So if you think about it, the even numbers are 2, 4, and 6. That's 3 out of 6 options. So 3 favorable outcomes, 6 possible outcomes. So we could say our probability is 3 out of 6, but we could also reduce that, and we could say our probability is 1 out of 2. Okay, so that's simple probability. It can get a little more complex, like if they use a deck of cards, or if you're rolling 2 sets of dice. If you're rolling 2 sets of dice, there's actually 36 outcomes. You can see that represented by this chart here. So just remember, if they're rolling 2 sets of dice, there's 36 possible outcomes. And if you look at it, there's multiple ways to get certain numbers. For example, the number 6, there's 1, 2, 3, 4, 5 ways to get the number 6, 4 ways to get the number 5, 3 ways to get the number 4, 2 ways to get the number 3. You guys should be noticing a trend here. And then there's 1, 2, 3, 4, 5, 6 ways to get the number 7, 5 ways to get the number 4, 4 ways to get the number 9, 3 ways to get the number 10, 2 ways to get the number 11. So just remember, if they're rolling 2 dice, there's multiple, there's 36 outcomes, and there's more than one possible outcome for most of your numbers, okay? Independent events, let's talk about that. So the last probability we're going to look at is a coin toss. So they say a fair coin is tossed 3 times. What's the probability that it comes up heads every time? So the probability is going to be 1 out of 2 for each individual toss. Now, if we want to know what the probability is across all 3 tosses, all we do is we multiply the probabilities by each other. So the probability of the first event times the probability of the second event times the probability of the third event, that would give us a total probability of 1/8. So it's kind of like a combination, the permutation problem and our probability problems. So if you have multiple probability events and you want to know what the outcome is for that specific sequence of getting a specific amount on every single step in the probability of events, then you're going to have to multiply all those probabilities together. To give you an example, I want to try to find not a coin toss. Let's find something a little bit different. Okay, here, let's do practice B. Roger rolls a pair of dice twice. What is the probability that in the 2 rolls he will get a total of 7 on the first roll and a total greater than 9 on the second roll? All right, so this is a good one. So we're looking for 2 probabilities, right? We want to know the probability of 7 on the first roll, and then on the second roll we want a probability that is greater than 9. All right, so like I said, if we're rolling 2 dice, that's 36 possible outcomes for each. Now, how many ways can we get the number 7? So if you remember from our chart counting down, there are 6 possible ways to roll the number 7. Now, when it comes to rolling numbers greater than 9, that only leaves us with 3 number possibilities, 10, 11, and 12. There's only one way to roll the number 12. So I'm going to go ahead and break this down because this is quite a few things to work with. There's one way to roll the number 12, which means that there are 2 ways to roll the number 11. And then that means there are 3 ways to roll the number 10, and then 4 ways to roll the number 9, 5 ways to roll number 8, 6 ways to roll number 7. Yep, that works. All right, so if you're ever looking for a number, you can always count that way. 7 is like the middle. 7 will always be 6, and then if you're counting 2, 7 from 1 or from 12, you always just count up like that. So that's 1, 2, 3, that's 6 total possibilities. So this is 1/6, and this is also 1/6. So the probability of rolling 7 and then greater than 9 is going to be 1/6 times 1/6, which means that the probability of making those 2 rolls in a row is 1 in 36. And that would be our answer for that problem. All right, if you guys have any questions, let me know on Moodle, and I will see you in class.